So welcome to Lesson 3.6, Assessing and Mitigating Cloud Vulnerabilities. In your Candidate Information Bulletin, we are in the Security Engineering domain. We are in Key Area of Knowledge E, which is Assess and Mitigate the Vulnerabilities of Security Architecture, Designs, and Solutions. Our topics are going to include Internet Cloud Computing, Middleware, and the Internet of Things. So we're going to be looking at three Internet architectures in this lesson: the cloud, middleware, and the Internet of Things. So we're going to start with cloud computing. NIST defines cloud computing as a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management, effort, or service provider interaction. So we often think about the cloud as all of those options that are available to us. They're off-premise and managed by somebody else. There are three main service models in the cloud environment: SaaS, PaaS, and IaaS. And there are a couple of different deployment models. There's a private cloud, there's a community cloud, there's a public cloud, and then in some cases you'll even see a hybrid cloud. It's really important to understand what the different service models are and the deployment models, so then you can be thinking about the type of due diligence that needs to be done for each of these providers, as well as understand what security controls the consumer, whoever purchases the use of the cloud, has control of, and what security controls that the provider has control of. And that's important because then you're going to want to be asking them for information or assurance about their set of controls. So let's look through the three service models and the three deployment models. The first is infrastructure as a service. So infrastructure as a service, which is abbreviated as IaaS, describes the offering of really sort of bare metal computing resources. The customer does not manage or control the underlying cloud infrastructure. The customer can provision processing, storage, networks, and other fundamental computing resources. That's where we're talking about the bare metal. They can get processing power, storage, network connectivity, and other fundamental resources. The customer does have control over the operating system, over storage, over deployed applications, and possibly some limited control over select network components. Sometimes there'll be a firewall that in fact the customer does have control over. That might be a host firewall, might even be a firewall that was provisioned specifically for that infrastructure. Platform as a service, PaaS, describes the offering of computing resources plus an operating system and sometimes a database. So the customer does not manage or control the underlying cloud infrastructure or the operating system. So that's important because operating systems need to continually be updated and patched. That's not under the control of the customer, that is under control of the service provider. Sometimes the database also is going to be under control of the service provider. The customer deploys onto the cloud infrastructure their own created or acquired applications. So the customer does control the application settings, and the application security. And the customer has control over those deployed applications and possibly configuration settings for the application hosting environment. So if there's an underlying environment, perhaps there's a web server that you're deploying your web site on, you may have control of some of the web server options as well. Software as a service, SaaS, describes the offering of the computing resources plus the operating system plus the application. The customer does not manage or control the underlying cloud infrastructure, which includes the network, the servers, the operating systems, storage, or even the individual application capabilities. The customer uses the provider's application running on the cloud infrastructure, and the customer may have control over limited user-specific application configurations. There's a really wide spectrum of control depending on which one of these three models you're going to be purchasing. In addition to our three service models, we have three deployment models, the first of which is a private cloud. The private cloud infrastructure is provisioned for exclusive use by a single organization. It may be owned, managed, or operated by the organization or by a third party. It may exist on-premise or off-premise. A community cloud infrastructure is provisioned for exclusive use by a specific community of customers that are generally known to each other. It may be owned, managed, and operated by one or more of the organizations in the community, or a third party, or some combination. It also may exist on-premise or off-premise. That's in contrast to the public cloud. The public cloud infrastructure is provisioned for open use by the general public. It may be owned and managed and operated by a business or a government organization. It exists on the premise of the cloud provider. So we have our private cloud, our community cloud, and our public clouds. The Cloud Security Alliance mission is to promote the use of best practices for providing security assurance within the cloud computing. And the CCA has published some top threats to cloud computing, including abuse and nefarious use of cloud computing. One of the concerns is that cloud providers don't necessarily vet their customers, so we can have customers who are using the cloud for abuse or nefarious purposes. There can be insecure interfaces and APIs between the cloud provider environment and the customer. There can be malicious insiders in the cloud environment that may end up with access to your critical data or systems if you're in the cloud. There are shared technology issues that may impact security. There could be data loss or data leakage between various customers. There could be account or service hijacking. Now, that's not to say that the cloud can't be a good environment or can't be a secure environment. It certainly can with the right controls. But as like in any other environment, as a consumer, it's important to understand what some of the weaknesses are or potential vulnerabilities in the cloud environment so that you can assess the risk and then mitigate the risk. So next we're going to look at middleware. Middleware is connectivity software that enables multiple processes running on one or more systems to interact. Middleware is the backbone of what is referred to as a service-oriented architecture, SOA, in which applications call other applications. So we'll often see this on the internet. We'll have multiple applications that could be owned and managed by various companies, but they call each other, they connect to each other. Our security considerations is that middleware interfaces are a target as they're a conduit to multiple environments. So if you can get to the middleware, you can get to all of the points that it's connecting. And not all middleware was developed with security in mind, and some middleware does lack end-to-end encryption. Middleware was often developed for performance opposed to security. So again, as part of due diligence and vetting, we really need to understand what middleware we're using in our environment and how that may impact a service-oriented architecture. And lastly, we have the Internet of Things, IoTs. From Wikipedia, we have a definition of the Internet of Things, which is the Internet of Things is a network of physical objects or things embedded in electronics, software, sensors, and connectivity to enable it to achieve greater value and service by exchanging data with the manufacturer, operator, or other connected devices. Each thing is uniquely identified through its embedded computing system, but is able to interoperate within the existing Internet infrastructure. The Internet of Things is very consumer-oriented. It's what turns on your light switches. It's what allows you to find your keys, perhaps. It's what's going to be in our cars, in our refrigerators. So all of these systems, which are, again, very consumer-oriented, are there for consumer convenience. Some of them are very cool. But you have to also recognize that they were developed with a bias towards usability and ease of access. And we think about the fact that they're all connected via the internet. So while it might be pretty cool that from your office you can turn on your heat at home and start making it warmer, the fact is that now you have those two endpoints on the internet, which does provide for a security context for a potential attacker. And in general, what's been seen to date is that the Internet of Things is being architected, deployed, and managed with a noticeable lack of attention to security. So if you're going to be putting an Internet of Things connected device onto a network that you have the responsibility of securing, you're going to look hard at that device to understand the security implications. So let's review what we've just discussed. We started with talking about cloud computing, including our three service models: our infrastructure as a service, our platform as a service, and software as a service, and then our deployment models of a private cloud, a community cloud, and a public cloud. We looked at middleware, and we looked at the Internet of Things. So that's going to bring us to our lesson 3.6, Match the Meaning. Grid computing, cloud computing, IaaS, PaaS, SaaS, a public cloud, a community cloud, and a private cloud. So I want you to take a look at the options in the right-hand column. I'm going to have you put me on pause. I'd like you to go match the meanings, then come on back and we'll go through them together. Grid computing is a sharing of CPU power across a network. We actually discussed that in lesson 3.4. Cloud computing is ubiquitous on-demand resources. So available to us on demand. We may not know where they're coming from. We may not know where the cloud systems are. We may not even know what country those cloud systems are in. IaaS, Infrastructure as a Service, provides bare metal resources. PaaS, Platform as a Service, provides bare metal resources plus an operating system plus sometimes a database. SaaS, Software as a Service, provides all resources except perhaps some end-user application settings. The public cloud is shared among all subscribers. A community cloud is shared among like subscribers within your community. And a private cloud is used for a single entity. So we're going to end this lesson with looking at our CISSP exam tips. A service-oriented architecture, SOA, is where applications can call other applications. The IoT, which is the Internet of Things, has a bias towards usability and ease of access, which means that they're sacrificing, in some cases, security. And lastly, due diligence must be conducted on cloud providers. Now, the amount and type of due diligence will also be directly related to the type of service provider and the type of platform that you're running. So thank you very much for joining me for this lesson, and I look forward to seeing you in the next.